This is Amireza Shafi'i. I am senior undergraduate student of electrical engineering at Amir Kabir University of Technology, Tehran Polytechnic. I have prepared a presentation which is titled Oxygen Sensor for Electrical and Electronic Measurement Systems course. Thanks in advance for Dr. Rihai's efforts. So what is the oxygen sensor? An oxygen sensor or a lambda sensor is an electronic device that measures the proportion of oxygen in the gas or liquid being analyzed. That is to say that it was developed by Robert Bosch during the late 1960s under the supervision of Dr. Gunther Baumann. Automotive oxygen sensors, colloquially known as O2 sensors, make modern electronic fuel injection and emission control possible. They help determine in real time whether the air-fuel ratio of combustion engine is rich or lean. Since oxygen sensors are located in the exhaust stream, they do not directly measure the air or the fuel entering the engine. But when information from oxygen sensor is coupled with information from other sources, it can be used to indirectly determine the air-fuel ratio. Closed-loop feedback controlled fuel injection varies the fuel injector output according to real-time sensor data rather than operating with a predetermined fuel map, open loop. In addition to enabling electronic fuel injection to work efficiently, this emission control technique can reduce the amounts of both unburned fuel and oxides of nitrogen entering the atmosphere. So, how's the oxygen sensor work? The sensor does not actually measure oxygen concentration, but rather than the difference between the amount of oxygen in the exhaust gas and the amount of oxygen in air, rich mixture causes an oxygen demand. This demand causes a voltage to build up due to transportation of oxygen ions through the sensor layer. Lean mixture causes low voltage since there's an oxygen excess. Modern spark ignited combustion engines use oxygen sensors and catalytic converters in order to reduce exhaust emissions. Information on oxygen concentration is sent to the engine management computer or engine control unit, ECU, which adjusts the amount of fuel injected into the engine to compensate for excess air or excess fuel. The ECU attempts to maintain on average a certain air-fuel ratio by interpreting the information gained from the oxygen sensor. The primary goal is compromise between power, fuel economy, and emissions, and in most cases is achieved by an air-fuel ratio close to stoichiometric. For spark ignition engines, such as those that burn gasoline or LPG as opposed to diesel. The three types of emissions modern systems are concerned with are hydrocarbons, which are released when the fuel is not burned completely, such as when misfiring or running rich. Carbon monoxide, which is result of running slightly rich, and oxide nitrogen, which dominate with the mixture is lean. Failure of these sensors, either through normal aging, the use of leaded fuels or fuel contaminated with silicones or silicates, for example, can lead to damage of an automobile's catalytic converter and expensive repairs. So, where is the car oxygen sensor installed? It is typically screwed into a threaded hole in the exhaust system located after the branch manifold of the exhaust system combines and before the catalytic converter. New vehicles are required to have a sensor before and after the exhaust catalyst to meet US regulations requiring that all emissions components be monitored for failure. pre and post catalyst signals are monitored to determine catalyst efficiency, and if the converter is not performing as expected, an alert gets reported to the user through onboard diagnostic systems by, for example, lighting up an indicator in the vehicle's dashboard. Additionally, some catalyst systems require brief cycles of lean oxygen-containing gas to load the catalyst and promote additional oxidation reduction of undesirable exhaust components. So, what is the structure of oxygen sensor? It has a ceramic body and electrodes made of platinum, and its sheath is made of subconical dioxide and has a heating element that raises the temperature of the sensor to 300 to 800 degrees Celsius. Here in this figure we have internal structure of the oxygen sensor, and here we have 4 bases. It is input base that is have 12 volt positive power from double relay. This is body connection, and this is negative signal, and this is positive signal. So, the oxygen sensor operation. This sensor is sensitive to changes in the amount of oxygen, and the tip of the sensor is inside the exhaust pipe, which reacts with the amount of oxygen in the exhaust and generates a signal and sends it to the ECU to correct the amount of fuel and air. If the exhaust is low, the fuel is rich and reduces the fuel by sending a low voltage signal. And if the amount of oxygen in the exhaust is high, the fuel is dilute and increases the fuel by sending a high voltage signal. So, the oxygen sensor failures. Normally, the lifetime of an unheated sensor is about 30,000 to 50,000 miles. Heated sensor lifetime is typically 100,000 miles. A failure of an unheated sensor is usually caused by the buildup of soot in the ceramic element, which lengthens its response time and may cause total loss of ability to sense oxygen. For heated sensors, normal deposits are burned off during operation, and failure occurs due to catalyst depletion. The probe then tends to report the lean mixture. The ECU enriches the mixture. The exhaust gets rich with carbon monoxide and hydrocarbons, and the fuel economy worsens. Another common cause of premature failure of lambda probes is contamination of fuel with silicones or silicates. In this case, the deposits on the sensor are colored between shiny white and grainy light gray. Some sensors have an air inlet to the sensor in the lead, so contamination from the lead caused by water or oil leaks can be sucked into the sensor, cause failure. Symptoms of failing oxygen sensor includes sensor lights on dashing indicates problem, increased tailpipe emissions, increased fuel consumption, hesitation on acceleration, stalling, rough idling. So my presentation is ended, and thanks for your attention, and hope you all have a good time, and bye.